here is another very interesting example that is called the bill of material. So, or we simply call this BOM, and this is the information about kind of structural information how to build a product using several different components or assemblies. This is very important information, particularly the manufacturing environment. For example, here in your company, you want to make clipboard, then you need one clip assembly, two rivets, and one board. Further, to make one clip assembly, you need one top clip, bottom clip, pivot spring, and further you have some raw materials like a sheet metal to make top clip, and so forth. So this is kind of tree-like information, structural information for all the parts in your company. So to implement this information using the relational database, we have to use some concepts that we have learned. In some senses, it's pretty similar to the employee relationship, particularly the recursive relationship that we've learned. In that recursive employee relationship, we use the employee, physically same employee table 2 times. One as a supervisor and the other one as a supervisee, or both or worker. Similarly, here in this bill of material information, look at each link. If you look at each link, we are describing parent and child. For example, here, if you consider this specific link, the parent is top clip, the child is sheet metal. So we have to describe this parent and child relationship, but if you consider top clip and sheet metal separately, this is just one instance of your part entities, part tables. So therefore, physically, one table, part table, should be linked conceptually, one as a parent part, but the other as a child part. And if you consider this relationship part as a parent and a child, one item, for example, sheet metal is here and the sheet metal is there. So one instance, like the same instance, sheet metal can be used as children in 2 different cases. So similarly, also parent item, one same item like a clip assembly can be parent of top clip, but also it can be parent of bottom clip. So what this means, if you consider parent parts and children parts, there is a relationship that is many-to-many relationship. So how can you resolve this? First, keep in mind we are using physically one table part, but conceptually we use this table in 2 different ways. One as a parent and the other one as a children. And this parent and the children entities, conceptually different entities are related, but it's many-to-many relationship. So to resolve this issue, we have to use a associative entity that can map this parent and child items. And by adding this associative entity, particularly here in this case, we call this assembly, and this assembly entity is mapping parent and child by using 2 different one-to-many relationships. So in this figure, you can see from part to assembly, there are 2 relationships, actually 2 one-to-many relationships. The first relationship is as a parent, one-to-many relationship. The second relationship is as a child from one-to-many relationship. So it's pretty similar to other, associative entity, pattern, like course registration. There is a course students and there is enrollment. But in that case, course is a separate entity and the students is another separate entity. However, in this case, physically we have only one part entity, but conceptually we divide it into two instances, two entities. That is parent and the other one is children. So using this table, we can keep the information about this BOM. For example, here, if you look at specific link from clipboard, you need to rebed. So clipboard is in this assembly table parent item, and the rebed is child item, and how many you need? You need 2. So you can describe this specific link from parent clipboard to child rebed. A little bit simplified example is here. So we have a few different parts, and here there is assembly table, and for one parent, actually it's a little bit simplified because we have only one parent. So for one parent 1000, we have how many child? We have children items 101, 2, 3, 4, 5, 6, 7, 8. Using this example, let's look at one practice query. So the query is list the product description and the cost of each component of the animal photograph kit. So what we need to do is, here using the part table, you may try to find this animal photographic kit. So part description, you read this. Here I found animal photograph kit. Then what you need to do? So here you may find the part ID 1000. Using this part ID 1000, I need to find the list of children items. So go to assembly tables, and when parent is 1000, what are the child or children product IDs? You have 8 children product IDs. So you have this the list of 8 children product ID. Using this list, come back to this product table, and you will describe part description and the cost of each component. Okay, so let's start to make those tables first, part and assembly. So part is the list of products or items we have. So we can just run this, create table statement and click go. So we created this table part. Now the create table statement for assembly is kind of interesting. So if you copy and paste this create table for assembly table, we have quantity, and here we have 2 columns called the parent PID and the child PID. And if you look at primary key, first primary key is the combination of these 2 keys. So parent PID and the child PID. Right? Therefore, this assembly entity is borrowing primary key parent PID from the product table and also child PID from the product table. So, 2 one-to-many relationships, the relationships are strong, but the assembly entity itself is weak entity. And also note that there are 2 foreign key constraints. So one for the parent and the other one for the child. So both foreign keys, parent PID, child PID is referencing same table, part tables, and both they are referencing same columns, part ID and part ID. That's right. But the first foreign key constraint is constraint for the parent PID, but the second constraint is child PID. So in this case, actually we are using different column names, parent PID, child PID, but both columns are referencing the same column in the part table. The column name is part ID. You can create it. So we have tables, assembly tables, and then to populate it, you may want to insert all the part information first. So let me copy and paste all the part information. So in this insert statement, if you look at the first item, animal photograph kit, instead of just listing values, we specify the columns. The reason is because we don't have the value for the part cost if you see the tables, so we have to specify the column names. But for other items, we have all the information for all the columns, so you don't have to specify the column names. So anyway, we can create all those instances for the part. Now we can enter the assembly information. So here we can set all the assembly information. Note that without existing part ID, we cannot insert this information here, because we are referencing those product informations while we are entering this information for the assembly. So let's click go. So now we created all the informations. Now it's time to create the query. So here we want to create a query SQL statement to list the product description and the cost of each component of the animal photograph kit. So let's start with a very simple query that is, we will look at or we will list up the children product ID where the parents part description is animal photograph kit. So what we are going to do is select child PID from assembly. So I will select child PID from assembly. But however, we have to look up the parent information. So we may need to use a part table as well, but part table as a parent. So we use these two tables, and the first condition we have is parent description. So in this case, part description. Part is used as a parent, right? So here part description is animal photograph kit, and we need to join part and assembly. In this case, join is based on which relationship? Parent relationship or children relationship? Yes, we are linking this part with assembly to look up the information for the parent part description. So here and we have part ID is, so part, if we type in part ID, this is the column in the part table. So part ID is automatically what? Parent part ID equals to, in the assembly table, now you have to be careful. Is it parent PID column or child PID column? It should be parent PID column. So if you run this, what we expect? We expect child PID from the assembly table when this parent PID in the assembly table is mapped with parent in a part table, and then in that case part description is parent's description, and that is animal photograph kit. So if you run it, you can get the list of child PID where the parent's description is animal photograph kit. So far so good. Okay, now using this list of children's product ID, how we can complete this SQL statement. Okay, we have the list. Then we wanna describe the information for each children. So we can write down another select statement outside. So let me move down a little bit. And here another select statement that is part description, part cost. So note that this part description, part cost is for what? Parent or children? Children. And from part, this part is used for children or parent? Again, it's children. And where now the condition is children's part ID is outside this part. So children part ID is, here we have the list inside this parenthesis. So how can we use this list? You can add which clause? Yes, in clause. So part ID should be in this list. So if this list, we can now show for 8 children items what are their part description and what is the part cost. Here is another approach we can use. It's more interesting. In this case, now we want to use 3 tables. I mean, logically 3 tables at the same time. So, listen carefully here. The logically 3 table means we will use assembly table definitely, but we will use part tables in 2 times. One as parent and one as child. So how we can use this? So we will use select statement, and here in this select statement, still we want to show what part description, and what else? We want to show part cost. So part cost, and here after then from clause, we will use part table once as a child and once as a parent, and also assembly table. So what we can do is similar to the employee table in the previous example. We can use areas, part as a child and also part as a parent. So by adding this, now we have 2 different part tables. So the part description, to avoid ambiguity, we have to specify that it's a child part description, and this one is a child part cost. And then what else we need to do? First, we may specify the where conditions. The given where condition is one is parent. Again, we are using the alias we defined here. So parent, what is that? Part description. So part description is given as animal photograph kit. So we specify this condition first, and then we have to join it. So we have to join actually conceptually 3 tables. So to join 3 tables, we need how many join conditions? 2 join conditions. So for the relationship for the parent, what we need? We need join conditions for, yes, alias parent. So physically it's a part table, but parent part ID should be matched with assemblies. Yes, parent PID. And there is another join conditions, that is child part ID is matched with assembly tables, which column? Instead of parent PID, we have child PID. So here the difference from the previous approach is, instead of using subquery, you can use 3 tables. Again, conceptually 3 tables, but physically 2 tables. And with this, since we are using 3 tables simultaneously, you need 2 join conditions. Since here we have 2 conceptually different tables, child and parent, you have to use alias parent and child. For each, you have to write down join conditions. So we have 2 join conditions, and there is 1 additional condition for the parent's part descriptions. So if you run this, you will get the same result. So please take some time to review this special example one more time. So how a product table is used in 2 different ways, and why we consider this as a kind of 3 table and 2 join examples. finally, we completed learning module 3. So we covered all the most of the important topics in the database design and implementations. We have one more learning module, the module 4. We will see how to develop a very small prototyping web-based systems that can use MySQL database that we implemented so far. So thank you for listening, and see you in the following learning module 4. Thank you.